This video is for the second half of Chapter 2, concepts ranging from scope to user input, and hopefully I can just keep this brief, highlight some of the key concepts, and give you some detail that you may not have gotten from your reading. If you have any questions, please don't hesitate to ask me in class. So starting with the idea of scope here, and as the slide says, scope talks about the parts of your program where variables essentially exist. Okay, so they're the part of the program that has access to your variable's contents. So what does that mean exactly? It means that even when you create a variable in your program, it only can be used for certain parts of your program. Okay, as the second bullet point here says, if a variable is declared inside a method, and so far the methods that we've seen have been main methods of programs, those are called local variables, and their scope is only for the extent of that method. In other words, they only can ever be used within that method. Okay, and there's a limit to the scope of a local variable even within a method. Okay, so hopefully you can see the code here. It's the example that we used in class, Snow Advisor. I'm just going to use it to show you how variable scope applies. So all of these variables that are declared here in the main method are local variables, and I'd like to talk about their scope. So let's look at plows available. Plows available is declared here on line 20, and it's also initialized to the value of 7. So 7 is assigned into plows available as soon as it's created. And that means that on any line after line 20 to the end of this main method, which is here on line 36, so on any line between those two, plows available can be used. Okay? If you tried to, so let's just take a quick look here. Line 24, line 25, we do a comparison. We have a conditional statement where plows available is compared to plows needed. So we're saying this statement, this conditional here, will be true if plows available is less than plows needed. Well, the reason we can do that, the reason we can use plows available in this conditional is because plows available was declared up here. If this if statement were before this declaration, that would not be legal. The program would not know about the existence of plows available, and you'd get an error. So just to demonstrate variable scope that has to do with being in or not in a method, I created a second method in this program called hi there, and you can see it here. And I've also made the console visible, so you can see that I've run the program and I've got some output in the console. I'll just run it again to show you that, yep, it creates that output. If I were going to use this second method, we haven't talked about calling methods yet, but if you have, so we've got the main method here. I'm just going to quickly add a call to this second method, and this is how you do it. You say hi there. Okay, you say hi there, and then there are no parameters. I had to make this thing static for certain reasons that we will talk about later. So this will call the function hi there. Okay, so if we run it, we can see what the purpose of that method is. What it does is it just prints out the message hi there. So that's all it does, because it's just got a print line statement. But now what would happen if in this second method I decide that I'm going to try to use plows available? So I'll say plows available. Actually, let me say hi there and then plus report on plows available. What happens? So I do this, save the program. Now you notice that it's not going to run. It already has given me a little mark telling me that there is an error here. So this is a little bit of a demonstration also of how you can use Eclipse to help you find errors in your program. Eclipse will always give you a little warning when there's a syntax error or other related errors that the compiler can find. And when you mouse over the symbol, so it underlines where it thinks the error is. Doesn't always know for sure, but this is the first place it notices the error, and then it gives you a little X, a little red mark here. When you hover over it, you'll see, and hopefully if you can full screen this, you can read that tiny text. You see that it says plows available cannot be resolved to a variable. That's because plows available doesn't exist in the scope of this other method. Right? It only exists in the method main, and only after it's declared and until the end of main, which is here. Okay, so it exists within that block. And one other quick thing I want to show you about Eclipse that has to do with blocks of code is that when you put your cursor, this might be difficult to see in the video, but when you put your cursor in next to one of these brackets, it will show you the corresponding other end of that block that bracket belongs to by highlighting it with a little a very light colored rectangle. So if I put it here, it will locate the matching bracket up there. Okay, so we have an error here. We have to resolve it. So we can do that a number of ways, but right now we're just going to delete it because this is just an example. And that's essentially how scope works. You just have to be aware that variables have scope, so sometimes you'll run into an error if you don't pay attention to that, and hopefully this will help you understand why you may get some of those errors. Okay. We've talked a little briefly about comments before in class. They're very important because they help document your code. In the lab, you encountered one way to use comments as a kind of a step between having a pseudocode algorithm and a finished program, in that you can actually write your pseudocode algorithm and write it in comment form, and then you can expand each comment into Java statements that accomplish what the steps of your pseudocode algorithm were describing. So we can talk in more detail about comments if you have questions, but really I'm only going to talk about the syntax of comments here. We have single line comments, so you can always put a comment after a statement by putting a double slash, // and then put your comment after the slashes. Okay, so the compiler will ignore any text you put there after the slashes, and then you just continue on, with the next line. The compiler will of course read the next line and everything. So these are single line comments, and they just allow you to put comments. They can be the entire line if you like, or they can come after something. Okay, and we actually saw examples of this. I put some single line comments in the Snow Advisor program for the variable declarations and initializations. We can have comments that span lines, so we can have multi-line comments, and this sort of comment is the kind of comment that you saw in the header comment that I'm asking you to include in all of your labs and homework assignments from now on. Okay, it starts with a slash and uses a star. That denotes the beginning of the block of comments, and then we end the block with a star and another slash like that. All the lines in between these two punctuation marks, these two delimiters, will be ignored by the compiler. And because of style differences in the way people like to do things, there's a lot of variation in how you can create comments. And a lot of this is up to the choice of the programmers. The syntax is the same. Double slashes means the compiler is going to ignore anything that comes afterwards, and /* means you have a block until you finish it with */. So you can you can decide that you'd rather put double slashes at the beginning of every line and do like block comments like this, or you can use this syntax. It's it's mostly up to you. It's more important actually that you use comments than it is the form of the comments. I'm not going to talk much about Javadoc, but just be aware that there are certain special kinds of comments, blocks that are that start with a double star instead of just one star, and they're read by a tool called JavaDoc that create documentation for Java classes, and people use these when they build libraries and such. And there are special words that can be used in those comments to tell about the attributes of an object, a class, its objects, and the methods and the data that are in there. So we're not going to do that ourselves, but we may benefit from reading some JavaDoc that other people have created. But just know that when you see this, to recognize it, when you see this in a Java class, that's what's going on, is people are trying to create comments that can be used by JavaDoc. So we're going to talk a little bit about reading keyboard input now. You've seen this in some programs before. You haven't written the programs yourself. You copied one program that had keyboard input, and I believe that you may have added keyboard input to one of your projects. We're going to talk about exactly what the statements that you added were doing now. Take a closer look. So one method of user input uses the scanner class in order to read keyboard input. So allowing people to type things in response to what the program is doing in order to make the program flexible to how a user wants to use the program. Okay? When I say using the scanner class, what I'm talking about is that there are a number of classes, a whole bunch of classes that are included with Java that they're like their own programs with their own functionality that are made available to all Java programmers for use in their own projects. So, for instance, someone somewhere wrote a class called scanner that knows how to get input from the keyboard. Okay? And when you import the scanner class into your program, now your program knows how to get input from the keyboard. Okay? So Java, one of the powerful aspects of Java is that it has many pre-existing functions and capabilities that are built into these libraries that come with Java. Okay? And one of those libraries is the util library, or utility classes, and you can get access to them by importing them into your program. So that's what this is talking about here, is that the scanner class is part of java.util, which is just a bunch of utility classes that are provided to you, but they're not imported into Java until you want to use them. So the reason that you are made to import classes that you want to use in your program is that it helps to keep your program kind of lean and less of a memory burden on the computer if you're only importing the resources that you're going to use. So if you know you're going to use input, then you go ahead and you will import java.util.scanner in your program at near the top of your class file, and then that tells Java that somewhere in this program you're going to use the scanner class, and then it allows you to use it, and then it knows exactly what it needs to do when it sees the scanner class pop up. How does the scanner class pop up? Okay, well, the first place you see it is in a line like this in your program, and you've already seen this in some programs. Okay, and it has an additional, when you see it like this, there's an additional feature that that isn't part of the scanner class itself, but it's System.in, and that's actually included as input into the creation of the object that you are making here for the scanner class. That's a lot of that's kind of a lot of explanation out of the blue. So let me just explain what the statement does step by step, and hopefully it will become clear. You actually are declaring a variable called keyboard, and this variable is going to be of type scanner. So in other words, the keyboard is an object that is of the scanner class type. So think of keyboard as a scanner object. Just like in a primitive variable, but in this case it's an object that instead of being of int type or of string type, it's of scanner type. Okay, and because you're creating this variable called keyboard, you can use it later on. But when a variable is a class type rather than a primitive data type, instead of just holding some information, it also has functionality. It has methods of its own that you can call and use. You may be familiar already with the way string works. It has some data and it has some functionality, and that's what, in this case, that's what keyboard is going to do for us. It's got some functionality of its own, and we'll see that when we use it. So we declare the keyboard to be an object of type scanner, and then we put into that space that we created, that memory location we created, we create a new scanner object, and then we initialize it by giving it this information. Now, that's a lot of stuff that that you're not going to be completely familiar with yet if you haven't programmed before. But now that I've explained some of the different parts of it, it may not be completely clear, but the one main thing that you should take away from this is that this creates the keyboard object and allows you to start using it, and it's going to give you access to system input. Okay, so for now you're basically going to, when you need to create input, you're going to put this line in your programs. This slide is a breakdown of exactly what's going on. So you'll find this in your book as well, but you can also pause the video and look at the explanation of the different parts. It's basically what I just said, but it's a little bit more in detail, and it'll give you a chance to review it to see which parts of it make sense to you, which parts maybe don't. So once you've created a keyboard object that is of type scanner, the scanner class has methods for reading different types of data that your user can type into the console from using their keyboard. Okay, this is a list of all the different types that can be read and the ways that it can be read, and you can find these in your book. But I thought that maybe we could do a quick example using some integer input just to show how that works. Okay. So here's our program back. I'm going to use it as the example that we read keyboard input for. Give us some flexibility here. Currently, when we run this, I'm going to remove the high there because that's no longer necessary. I'm going to remove this whole method just to streamline it. Okay. So now what we've got is the program that we had as an example in class, and when it runs it, it says it activates 7 plows because there's a set amount of snow accumulation here, which is 5 inches. Okay, now we have keyboard input here with the scanner. What if we wanted to have the weatherman enter the number of inches of snow depending on the actual snowfall? So we know that we want snow accumulation, okay, to be set to some new value. And what we're going to do is we're going to set it to a new value that is read in from the keyboard object, which is a scanner, which is of type the scanner class. So to access those features of the scanner that we have, first of all we use its name, keyboard. That's the name we gave it when we created it. Okay, and the way the syntax works here is if we want to call a method belonging to an object, we use the dot. Okay, so keyboard dot means give us access to some part of keyboard that is publicly available to us. And in this case, one of the methods that we're going to use to read the keyboard is available to us. So we say dot, and there's something called nextInt. Okay, so we're just telling it get the next integer that is entered from the keyboard, and then if you see an integer, just assign it into snow accumulation. Okay, and then this should work. So I'm going to save my file and I'm going to run it and see what it does. Okay, so now you see I'm currently running the program, and you should see that we can actually make this part bigger. Okay, so I increased the font size so that you'd be able to see it better. Right now, Eclipse is waiting for input from the console. So in a way, it's kind of hung, just waiting for me to just do what I'm about to do. And what it wants is it wants a number. So, but I'm a user. I don't know what to do. I'm just going to type in garbage, and I get an error. Okay, and the reason I did this was to show that I didn't know what to do. The user doesn't know what to do because the program did not provide any kind of prompt. Okay, so when you do user input, you want to create a prompt to tell the user what to do. Now I'm going to use cut and paste to put an output statement here, and I'm just going to say, I'm going to tell the user, please input the number of inches of snowfall. Okay? And this will basically give the user some information about what the heck it is that they're supposed to do. And there we go. All right, so I'm going to run it again. Oh, it asks me to save before I do that. And now it's giving me some information about what it wants. It's telling me what it wants. So now I can say, oh, all right, well, there was a whole foot of snow, 12 inches. Now it's changed a lot. The kind of output has changed from what we previously saw with 5 inches. It's telling me I need to contact the city for additional plowing assistance, activate 18 plows, that's a lot, and classes have been canceled as a result of this. And that's an example of how the keyboard input works. So the keyboard is not our only means of getting user input. In fact, you're probably much more familiar with getting user input through different widgets and things that are on the screen that are not just big console windows. For instance, whenever you have some kind of option that the computer needs to get information about from you immediately, you're probably familiar with seeing dialog boxes pop up in applications. A dialog box is just a screen element that pops up in its own new little window to either warn you of something or request some information from the user. And we can do this in Java using something called JOptionPane. And again, this is in a library. It's actually a library called Swing that gives us a whole bunch of different screen elements to use as programmers to communicate with the users. And you can use these dialog boxes to just warn the user of something, to tell them that there's some condition that has taken place, or to actually get input from them, to allow them to give you information by typing some information. But there's also a whole array of different controls that can be added to dialog boxes, most of which you'll be familiar with through your experience with software. Again, this is part of the Java libraries, so it's not immediately available to your program. It waits. Java programs only give you the bare minimum, the primitives and things like that. For other features, you have to actually import them into your projects. This is the import statement you use if you want to use JOptionPane. It tells the compiler where to find all the code of the JOptionPane class. And you'll be familiar with the kinds of things that you can get out of JOptionPane from your previous experience with software. It can be as simple as just a message that's asking you to click OK once you've acknowledged and read the message, or it can actually be a type of input. Any kind of information that the program needs. Often a dialog box is used if the program just can't continue until it gets that message. And why do I say that? Because often this is a dialog box that kind of blocks the rest of the program. The program can't go on. In fact, you won't be able to go on doing anything until you answer the question. So in a way, it kind of demands a response from the user before the program can continue. The simplest example that they have in the book is this hello world message. Using this exact statement, putting that anywhere in your program, once you've imported JOptionPane, you'll get a dialog box like this. I think JOptionPane is really cool because once you have JOptionPane in your program, you can throw these dialog boxes up. And I think it's really, I mean, when I program, I like to mess around with new programming languages. I like to see how we can put different interface elements in there and see how you can interact with the user. And it feels like you've accomplished something. It's kind of, I don't know, it's kind of nice. So I added JOptionPane to our program here about the snow accumulation, just in order to show you that there are some different options that you can do with JOptionPane if you look into it. So this is the same show message dialog that we're seeing here, okay? Except what I've done is I've used a different version of show message, the show message dialog call, which has additional options. And you can find this in references or in the book. I will give you access to references that give you all the sorts of detail that you could ever need for the Java libraries, and you can look through them. Swing is a really good place to look for things that you can add to your programs. JOptionPane is there. In any case, one of the versions of show message dialog gives you options beyond what beyond just what message to display. For instance, you can set the title of your dialog box. You can also set the type of icon that the dialog will display based on the type of message it's supposed to be. So I've added just a kind of a warning to stay safe in the winter weather, and this is a warning message, and I've changed the title of the dialog box. Let's see what that looks like. I'll run the program, and unfortunately the box appears on my second monitor, but I'll drag it over here so you can see it. Notice that the title of the box is different than the default. It says it's a weather warning, and the icon is different. It gives you a little caution kind of symbol, and there's my message, and then the program doesn't go on. Notice that nothing is displayed to the console yet until I click OK, and then it does its output. That's what dialog boxes do. Then that gives you a whole new kind of flexibility in your programs that you can add for interacting with the users. With different uses of JOptionPane, you can, instead of just displaying a message, you can show an input dialog, which actually gets input from the user. Here's an example of what that looks like. It just calls itself input, and you are allowed to put whatever message in here, whatever prompt you want to show the user. It will automatically put a little box in there for you. Puts a question mark because it's asking something of the user. So this is a nice detail that kind of alerts the user to what's going on, and then you get OK cancel buttons. And that's just another way to get information from the user. We could have done that in our program. One final detail is that using JOptionPane to open these other these dialog boxes, which are separate windows, actually does something kind of interesting in your program. It generates a thread. Well, there already is a thread. Whenever you run a program, that program is running in what is called a thread. A thread is kind of an independent, almost like an independent little machine that's running its own instructions, okay, on its own. You can have multiple threads going in a computer. Each thread will be like running its own program, doing its own thing, independent of the other threads. This is called multi-threading, actually, and this is one of the ways that computers are able to accomplish a lot without getting stuck. So, for instance, whenever they need to ask for user input, often if it was just one thread, if a computer only had one thread, and it was waiting for user input to do one job, then the entire computer would just stop waiting for that input. Nothing would be able to get done until the user input something. So what does that mean? Well, it means that if let's say you're running an email program on your computer and a game at the same time, and you're running this so you're the superintendent or something, or the mayor or whatever, and you're trying to decide whether school is going to be closed and whatnot. So you're running the snow accumulation program. Well, if all that is running in one thread, then as soon as the program started to ask for user input, everything else, the game, the email program, everything would have to just kind of halt and freeze until the user gave their input. And basically that's one way to describe that. Was we could say that the computer is hung. It's like hung up, stuck on something. So what the computers do is often when there are routines that need user input, they create dialog boxes or windows in completely independent threads that run separate from everything else that runs. So because the user input is operating in its own thread, its own like separate little imaginary machine, it's that little imaginary machine, that thread, that's hung up waiting for user input. Everything else is allowed to go on separately. So think of it that way. So when you use JOptionPane, you are creating an additional one of these threads in order to operate the dialog box. So because of that, you need to include in your program a System.exit call, or I should say a call to the System.exit method in order to completely exit your program. So this should be the last thing that runs in your main method if you're using any kind of JOptionPane or anything like that. So it's basically just understand that that needs to be included for you to do that, and so it's written like this: System.exit, open paren 0, and close paren. 0 has some meaning that's described here, but it won't generally be important for the things that we're doing in this class. And as you can see, I added a System.exit just now to our program so that it operates correctly. We get our winter weather warning, we say OK, and then the program is going to exit normally and safely. And one of the reasons that System.exit is important, obviously, it stops all the threads. One of the other things it does is it releases all of the resources that your program is using. So whenever we import things like JOptionPane and the keyboard, the scanner for doing keyboard input, the computer tells, or I should say the program tells other parts of the computer that we are using those things, that those resources are being used, and it allocates memory space for those things. And when you're doing that, the rest of when you are allocating those resources, you're basically saying that they can't be used by other people. So when your program is done running, it should do something to tell the entire rest of the computer that it's done using all of its resources. And when you call System.exit, you're kind of putting a period on the end of the sentence of your program. You're saying, we're done, this is final, we release all of our resources, we don't need them anymore. And that is one way to make your program a kind of polite user of the software environment that you're running it in. So that's scope and user input in Java. I hope that was helpful. If you have any questions, feel free to bring them up with me in class, in email, or during office hours.